Okay, so in this video we're going to be talking about mathematical patterns. So in this chapter we're going to be talking about sequences and series. So sequences is an ordered list of numbers. Series is going to be when we're adding and subtracting numbers. The biggest thing about this chapter is just the vocabulary. So each of these are, like this one here is called a sub 1. It's like a with a little 1, and it's representing your first term. Okay, the a is not going to be replaced. The whole thing could be replaced, but a is not going to be replaced with a number. So you just have to realize it's a sub 1. The next one would be a sub 2, a sub 3, and they all stand for certain terms. So this would be the first term because it's a 1, second term. Down here we have the nth term. So if I plug any number in for n, that would be the nth term. It's the same as when we talk about point slope. Okay, this is y sub 1 and this is x sub 1. Okay, so it's kind of saying the exact same thing. So they're going to represent different terms, and they're little numbers. It's not like a times 1 or a times 2. They're little subscripts. Okay, so the explicit formula has to do with the nth term. Recursive has to do with the term before it. Those are the big things. The term before it, so when we talk about the term before it, it's going to be a sub n minus 1. This nth term is going to be talking about when we have just n's in them. And they will always start out with a sub n equals blah, blah, blah. Okay? So the nth term is like, hey, if I have this first term, the n would stand for 1 because a sub 1 would be the first term. The recursive formula is going to be a lot harder because we care about the term before it. So that means if I'm trying to find the 8th term, I need to find 1, 2, 3, 4, 5, 6, 7 to get to 8. You care about all the things that happen before it to get to that term. Explicit. If we look, this this 9 is replacing the n. So all I'm going to do in here is replace my n with the 9. So the 9th term then would be 12 times 9 plus 3, which would be 111. Same thing with the other one. The 8 is replacing the n in this one, so a sub 8, or the 8th term. We plop our n in. So 8 squared is 64 minus 10 is 54. Okay, so explicit is really easy to plug in. It's harder when you have to make the equations. But when we're just trying to find a specific term, all we're plugging in is our n because we care about the nth term. So whatever our term is here is what we're plugging in. The recursive formula is a lot harder because we have to find all the ones before it to get to it. That's what the n minus 1 stands for. Okay, so I have this one, so my next one I need to find is the second term, so a sub 2. So I'm going to plop that 2 in for n. So it becomes 2 minus 1, because this is the formula I'm plopping it into. Okay, and then we're going to simplify. 2 minus 1 gets me 1. I have a sub 1 representing 4, so I can take it out and put 4 in, because we have to use the term before it to get to that term. So 4 times 2 gets me 8, 8 plus 3 gets me 11. All right, so there's the second term. I'm trying to get to the 4th term, so now I need to find the 3rd term. So we're going to plug 3 in for a this time. And we're going to simplify. So 2 times a, 3 minus 1 gets me 2. You have to use the term before it to get to the next one. So a sub 2 we found out was 11. 2 times 11 gets me 22, plus 3 gets me 25. There's the 3rd term. Now we got to find the 4th term. So a sub 4 equals 2 a sub 4 minus 1 plus 3. So the 4th term is 2 times a sub 3 plus 3. We already know what a sub 3 is, which is 25. So my 4th term then would be 2 times 25 is 50 plus 3 is 53. And that was my end game. Okay, so recursive is poopy because you have to find all of the terms before it to get to yours. That's what the n minus 1 stands for. Okay, so this one, my equation is this. We're starting it at 8 and we're trying to get to 15. So I give you the 8th, so I need to find the 9th next. And I'm going to plop that 9 in for n. So that's going to get me 9 minus 1 gets me 8. I know what a sub 8 is. It's 7. So I'm going to plop 7 in there now. So a sub 9 equals 49. Then we got to find a sub 10. So now I plop the 10 in there. So a sub 10 equals 10 minus 1 gets me 9. I know what a sub 9 is because I just found it, and it is 49. So then I square 49 to figure out my 10th term. So my 10th term is 2,401. Okay, so sometimes you can notice a pattern that happens in this. We're actually squaring whatever our term is before it to get to our next one. So my 11th term would then be 5,764,801. So you're squaring each one so you could find the pattern and then write from there. I just wanted to show you kind of how this can be really tedious when you're doing recursive. So you want to try to avoid this if you can, because my answer is going to be gigantic because we're going to keep squaring until we get to the 15th term. Okay, this one we are trying to find the recursive. Okay, and remember recursive, you have to have the a sub n minus 1. That's the one where we care about what's happening from the first term to the next term. Okay, so all of them start out with a sub n equals. Okay, and then we're trying to figure out what's happening from one term to the next. So how do I get from 4 to 8, 8 to 16, 16 to 32, 32 to 64? So it looks like we're multiplying each one by 2. So I'm taking 2 and I'm multiplying it by the one before it to get to my next one. This always stands of what's before it. So you can check it. So if I wanted to check it, I'm going to find out my second one here. So I would do 2 minus 1 because I plop my n in. 2 minus 1 gets me a sub 1. Well, my first term is 4. So a sub 2 is 2 times 4, which gets me 8. And that means, hey, my second term is 8, which is what my second term is. So that is my equation. My next one here, I'm going from 1 to 4, 4 to 7. Looks like I'm adding 3 each time. So my one before it, I'm adding 3 each time. Okay, these ones we are doing explicit, so that's when we have n's in our equations. And remember, n is the nth term. So when I plug in, let's say I'm talking about my first term, I'm plugging 1 in to get what I want. If I'm talking about my second term, I'm plugging 2 in to get what I want. When I talk about my third term, I'm plugging 3 in to get this. So what I do is I put a 1, 2, 3, 4, 5, because those are the terms that they are. So when I plug those terms in, those nth terms, I should be getting 4. When I plug 2 in, I should get 7. When I plug 3 in, I should get 10. So how do I go from 1 to 4, 2 to 7, 3 to 10, 4 to 13? Okay, so this one we're actually multiplying by something and adding something. So they all start out with a sub n again. Okay, so I'm actually in this situation multiplying my n by 3. So my nth is that number here, and I am adding 1 each time. Okay. So I need to do the 10th term. So if I was trying to find a sub 10 or the 10th term, I plop 10 in and I simplify. 3 times 10 gets me 30 plus 1 is 31. Okay, my next one, I have to go from 1 to 1, 2 to 4, 3 to 9. So when I plug this nth term in, I get these answers. Okay, so it looks like I'm squaring all my n's this time to get there. 1 squared gets me 1, 2 squared gets me 4, 3 squared gets me 9. To find the 10th term, we plop 10 in. 10 squared is 100. So those would be my answers for that one. Okay, my last one here, find the nth term of each sequence. If it's something really, really small and I'm already giving you a set, what I would do is just find what's being done each time and then take it out till you get to the 9th one. So this is 1, 2, 3, 4, 5. Okay. So it looks like I'm subtracting 2 each time. So my 6th one would be 32, 33, 31, 29, 27, so 7, 8. There's my 9th term right there. It's a lot less work than having to find the recursive formula or the explicit formula. So my next one, it looks like we're dividing 2 each time. So I have 1, 2, 3, 4. So my next one's going to be 2.5. My next one is going to be 1.25. I go 0.625. We're just dividing each of these by 2, 0.3125, and then 0.15625. And that's going to be my 9th one in that.